All right. Welcome back. Section 8, 9, perfect squares. This is the last section in Chapter 8, which has been a long chapter, but this is the last one. And this is one that we call a shortcut section because it gives you little shortcuts, but you don't necessarily need to use it. If you want to factor the way that you've been factoring, well, then you can do that. Those will still always work, but this is a way to go a little bit faster, a little quicker with a shortcut. If you remember back in, like, I think it's section 8.4, we were multiplying. There was a couple shortcut sections there, and you could just do FOIL or do the distributive property still, or you could use the shortcut. Same kind of deal here. So we're going to factor perfect square trinomials and then solve equations with them. So what is a perfect square trinomial? Oh, okay, there it is. It's a trinomial that is in the square of a binomial. So, for example, say 2a minus 5 squared. Okay, something written like that. And just kind of remember, just to look back at 8.4, remember the shortcuts for squares of sums and differences down here. So when you had like y minus 7 squared, so if we took this thing here, y minus 7 squared, remember you could write that out and be, well, y minus 7 times y minus 7 when you square it, right? And then what our shortcut said is if you FOILed it, y times y would be y squared. And then you've got a negative 7y here and a negative 7y here. And then 7 times 7, negative 7 times negative 7 was a positive 49. And we know we could combine these middle terms here and go y squared minus 14y plus 49 would be our trinomial, okay? Now remember, there was a shortcut method that you could use there because it was a perfect square, and you could just kind of double this value and put it in as the middle b term, okay? So now we're talking that this is going to be a factoring shortcut. So use your factoring options. Okay, so I'm just going to move this for a little bit. Use your factoring options, all right? So obviously now what we're going to do is the opposite of that. We're going to give you the trinomial of y squared minus 14y plus 49 and ask you to factor it. So we're using now basically the opposite of that factoring shortcut, okay? So what the shortcut says is if you have perfect squares, then you can go ahead and shortcut it. So if you know that this thing here, the square root of y squared is y, and then this one over here, the square root of 49 is 7, well then you know that we could say, all right, y minus 7, it'd have to be a minus because of this minus sign here, y minus 7 squared would be your answer there for the shortcut. That's all the shortcut kind of tells us to do. So if you can notice that you got a perfect square on the first term, your a term, and a perfect square on your c term, well then you can kind of take this number here, the y, and this number here, the 7, put them together. You've got to have a minus sign because we're minus b, so you got to have a minus sign and do that. That's one quick shortcut. But if you don't have to do it, you can use your factoring options. So, and obviously, I know you're smart enough to see that this is the exact opposite of this problem up here. So, yeah, you could easily get that it's going to be y minus 7 squared, but we're looking at the shortcut. But you don't have to use the shortcut. And but there's an easier way. Then if you can't tell if they're perfect squares right away, then one thing you can do is a couple steps here, and we'll show you that one as well. Okay, so the first step here is going to be to do a product sum table. Now, I know we did like a I know that we did a square method in one of our sections. So if you're a square method person, you can keep doing the square method. You're just going to have to factor it all out altogether. But if you do the product sum table, then you can actually use the shortcut, right? So after you do your product sum table, if you look and see that if the values and signs are identical, then you don't have to break apart B. So you know how, remember when we factored, we had to break apart B into two different terms? Here, you don't have to do that if you have the values and signs are identical. So then we can jump right ahead to a factored solution, square root of A plus or minus the square root of C squared. Okay? So let's take a look at doing this. So if we did a product sum table on this one, remember your product, here's our A value, here's our B value, and our C value here. Okay? Remember our product, we're trying to go A times C, which in this case would be 1 times 49. So we're multiplying to get to 49, and then you're adding to get to B. So you're adding to get to a negative 14, because that's our B value. So we know, of course, that 7 times 7 gives us 49. But if you were to add those up, 7 plus 7, you get a positive 14. So how can we change the sign and still have them multiplied to 49? Well, if we change it to negative and negative, we still know that a negative 7 times a negative 7 is still a positive 49. So we're good there. But then here, if we go negative 7 plus negative 7, now we get a negative 14. So now we're in business. So that means now we can go right to the shortcut method and say, all right, I don't need to break apart B. That's going to go away. I'm just going to take the square root of my A value, which is, we know is Y. Take the square root of my C value, which is 7. And then it has to be a minus sign because of this minus here. And that's the way to do the shortcut. Okay, so let's kind of look at some other examples here and see how we can do it. First one says determine if it's a perfect square. If so, factor it. Okay, well, I don't really want to go and try to determine it. Let's do a product sum table, and it should tell us right away. So if, again here, I'm multiplying to get A times C, and I'm adding to get my B value here. Okay, and here, A is 25. B is negative 30, I get in the habit of doing this, and C is 9. So I'm trying to go 25 times 9. A times C is 25 times 9, so I'm looking to multiply to 225, and I'm looking to add to a negative 30, because that's my B value. So when I do that, again, it helps if you know perfect squares, because if it is a perfect square, then you can do the shortcut. So 225, the square root is 15. So if I go 15 times 15 here, I can get 225. But if I add those up, remember I'm going to get a positive 30 here. So I've got to change the signs. Again, negative times a negative makes it positive, so I'm good on that side. Negative 15 times negative 15 is still 225. And then here, a negative 15 plus a negative 15 is going to give us our negative 30. So now I can take the numbers from the table and do that square root right in there. Okay, so now I can jump to, because I've got the numbers are identical and the signs are identical, which means I don't have to break apart B. So when I use my shortcut here, I can just say, all right, the square root of A is going to be 5x, right? And then I can take the square root of C, which is 3. And again, I've got a minus sign here, so that means the minus sign's got to be in the middle, and away I go. 5x minus 3 squared would be my final answer there. Okay? If you don't like the shortcut, you could still factor this out. You could actually do that, and if you wrote that out, remember it would be 5x minus 3 times 5x minus 3 if you wanted to continue to factor it like you normally do. But this is kind of what you'd end up getting. Okay? And you can distribute that or FOIL that to see if you got the right answer. Okay, we're just trying to use the shortcut, so that's kind of what I did. Once I saw that these values were identical and the signs were identical, and these values were identical and the signs were identical, then I was good to go and take the shortcut. Square root of A, square root of C, and a minus sign in here because this is a minus sign. All right, let's take a look at number 2. All right, number 2, we've got A is equal to 9, B is equal to 12, and C is equal to negative 4. Okay, so if I go ahead and do my product sum table here, I am multiplying to get a 9 times a negative 4, so negative 36 for multiply, and I'm adding to try and get my B value of 12. Okay, So if I do this, notice I got a negative here, so that's kind of tricky because now I know one value has to be positive and one negative. If I want to get them to be identical, it'd be 6 and 6, but one has to be a negative because I can get a negative answer. Negative times a positive. So now if I take those and add those up, negative 6 plus 6, I'm going to get 0. That doesn't quite work for us. So what you're going to look at is you're going to see it can't be factored. So I wanted to show this example just because it shows you that there's no way that we can do this. Or you'd have to factor it a different way, but there's no way we can use the shortcut. In this case, it can't be factored, so we would say it is prime. Remember, prime numbers can't be factored. Same with prime trinomials. All right. Now, number 3 is a little bit different because there's one sign that changed. This changed from a negative here to a positive here. So now let's try to do it. If I make a product sum table, again, now my A is 9. My B is 12. Let's stay the same, but my C is a positive 4 this time. So now when I do my product sum table, I am multiplying 9 times 4 to get a positive 36, and I'm adding to get a 12. Okay, so now when I do this, I can go 6 times 6. That'll give me 36. When I add those up, 6 plus 6 equals 12. So now I'm in business. I got identical numbers, identical signs, and so I can kind of roll here and do the shortcut method. The shortcut method tells me that, hey, I can take the square root of this term. Square root of 9y squared would be 3y. I can take the square root of this term, which is 2. And then I've got a plus sign here, which means that I'm going to have a plus sign in the middle there. That would be 3y plus 2 squared. Okay? So that is kind of the shortcut method for factoring trinomials. Let's take a look at how to solve now. Remember when we solved different equations and solved different when we factor in, we solved. Nothing really is going to be different here. We're still going to make sure the equation equals 0. That's our first step. The second step then is to look for a greatest common factor. If you can pull out a greatest common factor, then let's do that. And then the third step would be to factor the trinomial. And remember, when we factor the trinomial, that means we should get answers in parentheses. The fourth step is really the only different thing here. And we talked about this a long time ago, but take the square root to get rid of the square. And really, you only want to do that if you're using the shortcut method. If you're going to go ahead and factor it like we normally did, then you can solve it like we normally did. But if you use the shortcut method, you'll take the square root to get rid of the square, and we'll show you an example of how that works. And then, of course, we set each expression equal to 0, and then we solve it. So nothing too crazy there. All right, so let's work on an example. Let's do example 2 over here. Okay? So the first thing I notice as I look at my list is that I got to make sure the equation is equal to 0. This one is not. So I'm going to subtract this 24y, subtract this 24y, and I want to rewrite it, and I want to write it in standard form where I got descending order. So 4y squared minus 24y plus 36 equals 0. So now I've got it, everything on one side of the equation and equal to 0. All right, the next thing I want to do is look for a greatest common factor. Is there anything that they have, all three terms have in common? And it looks like 4 goes into all of those. So 4, I could factor out a 4 and have y squared. Looks like minus 6y. And then plus 9. All equal to 0. All right. So now what I'm going to do is I'm going to take and try to do the shortcut method if I can. So I'm going to use a product sum table. Again, I'm just going to list my A's, B's, and C's. My A is, in this case, I'm just looking inside the parentheses here. So my A value is 1 because I got to factor the trinomial. That's my next step. So my A is 1, my B is negative 6, and my C is 9. So when I do a product sum table here, what I'm going to end up doing is I'm going to take, sorry, I'm going on number 1 here, but oh well. I'm going to multiply to make A times C, which is 1 times 9, which is 9. And I'm going to add to make my B value of negative 6. So positive 9 multiplies to positive 9 and adds to negative 6. So in this case, what I'm trying to do is if I go what times what equals 9, well, it would be 3 times 3 is the first thing that comes to my mind. But when I add those up, I get 6. Okay, well, I would need a negative 6. So how can I do that? Again, if I change it to both negatives, still gives me a positive 9 when I multiply. And if I have these, negative times a negative plus a negative, I'm going to get a negative 6. So again, now I look at my table. I've got identical values in 3s, identical signs in negatives, and I'm in good shape to go to use the shortcut. So the shortcut says, take the square roots of the a value and the c value. So this 4 is still going to come down. I'm not doing anything different with that. I'm going to take the square root of this, which is going to be y. Then I'm going to take the square root of my c value, which is going to be 3. And I've got a negative sign here. So that means that negative sign is going to follow me down there, and I'm going to have y minus 3 squared. Okay? Now, if you don't, again, I'm just pointing this out again, if you don't like the shortcut value, you can always go ahead and do the long way. Okay? But let's just take it from right here, from our answer spot, and say if we were to write this out now, 4 times y minus 3 times y minus 3, right? That's all it would be. When we write out that square. Okay, so now when we try to solve this, our last thing is to set it equal to 0. Well, if you take each expression, 4 equals 0, well, we know that's not true, so that's not going to be our solution. And over here, I get y minus 3 equals 0. So when I add 3, I know that y is equal to 3. And over here, I'm going to get the same thing, right? So y equals 3. So when I make my solution, put it in set notation, I really only have to write it once because it's the same number. And that's what I can do. Okay, that's easy. Now let's just take a look if we wanted to go from over here. Now, if you like this way of doing it that we just did, then go ahead and do that. Like I said, it's never going to be wrong for you. Okay, make sure this is equal to 0. But now let's solve it this way. So what can I do if I look at this this way of factoring over here with the perfect square? What can I do to solve this? Well, if we solve things, a lot of times what we're going to do is we're going to divide. It's basically 4 times y minus 3. So if I divide by 4, that's going to cancel those out. Remember, you got to divide on both sides. So that would give me a 0 divided by 4. So I'd be left with y minus 3 squared equals 0. Now here's where we're going to take the square roots. Okay, take the square roots of both sides. And then what does the square root of a square do? I think we've talked about this before. Square root of a square actually is going to cancel all that out. They undo each other. So the square root of a square is going to be y minus 3. And the square root of 0 is 0. You can double check that in the calculator if you want, because I know that's correct. So now I undid the square. So now it's just y minus 3 equals 0. So now I'm just trying to solve here. Add 3, and y equals 3. And in solution set, that'd be 3. Okay, so it doesn't matter whether you do it here on the left side in blue or on the right side that we did in purple. As long as you get your solution set of 3, that's all that we're really worried about. Okay, we can practice more at a different time. I think it's good enough. So the lesson summary today, do you think you take the factoring shortcut, or are you going to factor like previous problems? And then give me a reason why or why not. And then here, let's solve. You got to solve this. Remember, you have to factor it first. And I'm just going to give you a little tip. Remember, we can't do this without it being equal to 0. So make sure we subtract 2x. And we end up with x squared minus 2x plus 1 equals 0. And then solve and factor that one. And just, again, remember, put your answer in a solution set as well. Okay, that's the end of chapter 8. Section 8-9 is done, and that's the end of chapter 8. So good luck with the rest of the chapter.